Hi, this is Mrs. Robertson, and today we are going to learn about how to factor expressions. The lesson today is located on page 415 in your math book. The title of it is Factor Linear Expressions, Lesson 8. So, we're going to go ahead and start with page 416, where it asks you to find the greatest common factor of a monomial. Monomial. Now that's a different word you've not heard before. And let's see here. We're on page 416. A monomial is a number, a variable, or a product of a number and one or more variables. Here we have an example of a monomial: 25x and 40x. These are examples of things that are not monomials. X plus 4, 40x plus 120. Now, to factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. The greatest common factor, or GCF, of two monomials is the greatest monomial that is a factor of both. Now, let's look at the examples, and I think it'll start to make a little more sense to you. First, in example 1, you will find the greatest common factor of each pair of monomials. What do? You list the prime factorization of each number. Now remember, prime numbers are numbers that have only two factors, one and the number itself. It's very important that you do the prime factorization. So, the prime factorization of 4x. 2 times 2 times x. 2 times 2 is 4 times x. Are they prime numbers? Yes, 2 is a prime number. Prime factorization of 12. 2 times 2 times 3 times x. Now, if you don't remember how to find your greatest common factor, I think if you just a factor tree, here's the 12. What times what is 12? 2 times 6. You circle the 2. What times what is 6? 2 times 3. You circle the 2 and the 3, but whenever they're a prime number, you circle them. And that is how you come up with 2 times 2 times 3. And then you add the x, since the x is the variable with that. Now, you circle what they both have in that is alike. They both have a 2, they both have another 2, and they both have an x. So, 2 times 2 times x gives you the greatest common factor of 4x. Let's do another example. In number 2, example 2, 18's prime factorization, in case let's just practice this. 2 times 9, 2 is prime, 9 is not prime, 3 times 3 equals 9. That's how they came up with 2 times 3 times 3 times a. Now, for 20 times a times b. The prime factorization for 20, 2 times 10, 2 is prime, 2 times 5. So you will have 2 times 2 times 5 times a times b. Now, what do they both have alike? They both have a 1, 2, and they both have an a. So the greatest common factor will be 2 times a, or 2a. Catching on? I hope so. Let's look at the next example. In example 3, here we have 12 and 36. The prime factorization for 12, 2 times 2 times 3 times c times d. The prime factorization for 36, 2 times 2 times 3 times 3 times c times d. What do they both have alike? They both have a 2, they both have another 2, they both have 1, 3, they both have a c, and they both have a d. So, the greatest common factor will be 2 times 2 times 3, which will be 12, times a c times a d. Now, I would like for you to try finding the greatest common factor of monomials in A, B, and C. You can put this on pause and then check your answers. All right, welcome back. So, for letter A, the prime factorization for 12, 2 times 2 times 3. The prime factorization for 28, 2 times 2 times 7, 28C, times C. What do they both have alike? They both have a 2. They both have another 2. So 2 times 2 equals 4. Its greatest common factor equals 4. B. In this problem, your prime factorization for 25x, 5 times 5 times x. For 15xy, your prime factorization is going to be 3 times 5 times x times y. They both have a 5 and they both have an x. So it's going to be 5x. The greatest common factor, 5x. Now this is not too bad. Let's go on to letter C. All right, the prime factorization for 42. Let's do a factor tree. 2 times 21. 3 times 7. So the prime factorization for 42mn will be 2 times 3 times 7 times m times n. Then for 14mn, it'll be 2 times 7 times m times n. All right, so you circle the 2, circle the 7, the m, and the n. So the greatest common factor will be 2 times 7 times m times n, or 14mn will give you the greatest common factor for that group of monomials. Now let's learn how to factor a linear expression on page 417. You can use the distributive property and the work backward strategy to express a linear expression as a product of its factors. A linear expression is in factored form when it's expressed as the product of its factors. All right, so here we have 8x plus 4y. They've broken 8 down into 4 times 2x and 4 times y. They found the greatest common factor of 8x and 4y is 4. So they pulled the greatest common factor out. So when you refer to it as the distributive property, it's 4 times 2x plus y. Let's look at example 4. Factors of 3x plus 9. In the model method, the x is represented with 3 green rectangles, the 3x, and 9 is represented with 9 little squares here. All right? And what they do is they find, oh, there's a 3 in each one. They factor out the 3, and then they get 3 times x plus 3. I think the model is a little more confusing than doing the method 2 here that they have. Method 2 is my preferred way of doing it. So, what's your greatest common factor in 3x and 9? It is a 3. So, you pull the 3 out, and 3 times what will get you back to the 3x? Well, 3 times x equals 3x. And 3 times what will take you back to the 9? 3 times 3 is 9. So here we end up with 3 times x plus 3 is the factored way of saying or it's the distributive way of factoring 3x plus 9. But once again, you're pulling out your greatest common factor. Okay, now let's go to example number 5. In example number 5, the way I suggest you do these, all right, there's a plus sign there. You're going to do something here. You're going to put something there, and we have to pull something out. What do we pull out? Your greatest common factor. That is what you're going to pull out and put here. So you look at 12x and 7y. What do they both have in them that's alike? Well, the only thing, here they list the factors, they have nothing in common. So there are no common factors for 12x and 7y, so it cannot be factored. So the way I had this problem set up, we can't use it for this one because they do not have it doesn't have a greatest common factor. So let's go ahead and look at letters D, E, and F, and we will use this setup to apply to D, E, and F. Okay. Here we are subtracting instead of adding. What is our greatest common factor in 4x and 28? 4. You're going to pull the 4 out. 4 times what is 4x? 4 times x will give you 4x. 4 times what is 28? 4 times 7 is 28. So 4x minus 28 can be factored to 4 times x minus 7. Now let's look at letter E. A plus sign. All right. Now, what's going to be my greatest common factor here between 3x and 33y? It will be a 3. So you pull the 3 out. Now 3 times what will give you a 3x? 3 times an x. 3 times what will give you 33y? 3 times 11y will give you a 33y. Now we look at letter F, 4x plus 35. There is no common factor for 4x and 35, so it will just stay the same. It's already factored. All right, now let's go on to the next page, page 418, and look at example 6. In example 6, it says, the drawing of a garden at the right has a total area of 15x plus 18 square feet. This representing that part of the garden, the 18 representing the smaller portion of the garden. Find possible dimensions of the garden. Well, it says factor 15x plus 18. Here they list the prime factorizations. They both have a 3, so the factor will be 3. 3 times 5x plus 6. So the possible dimensions are 3 feet by 5x by 6 feet. That is the answer to that problem. Now, let's do the guided practice together on page 418. Okay, so here we're going to do the prime factorization of 32 and 18. 32. Well, I know 4 times 8 is 32. 4 will break down into 2 times 2. 8 will be 2 times 4. And 4 will break down to 2 times 2. So for 32x, that will equal 1, 2, 3, 4, 5 2s and an x. 1, 2, 3, 4, 5 2s and an x. 18 will break down into 2 times 3 times 3. Now, if you don't know what the prime factorization of 18 is, you can go ahead and do a factor tree. for it. All right, what do they both have in them that's alike? They both have 1, 2. So the greatest common factor is 2. 27s and 54st. Factors for 27. 3 times 3 times 3 times s. For 54 st, 3 times 3 times 3 times 3 times 2 st. 1, 2, 3, and an s. So that is going to equal 27s. In the next problem, in number 3, they both have a C and a D, so I'm going to go ahead and put the C and the D down. Now, between an 18 and a 30, your greatest common factor will be 6. 6 divides 18, 6 divides 30. I think that is your greatest common factor. Once again, you could break it down. 18 CD equals 2 times 3 times 3 times C times D. For 30 will break down into 2 times 3 times 5 times C times D. They both have a 2, they both have a 3, a C, and a D. All right. Now, in the next group, it asks you to factor each expression. Use if the expression cannot be factored, write cannot be factored. Use algebra tiles if needed. All right, in this problem, I am looking at my 36 and 24. I know that my greatest common factor between a 36 and a 24 is a 12. So, this is one where you set it up like this. 12 times what is 36x? 12 times 3x will give you 36x. And 12 times 2 will give you the 24. So 12 times 3x is 36x, and 12 times 2 will take you back to the 24. So you have factored out the greatest common factor, 12, and then what's in the parentheses is what you would multiply to take you back to the original. Okay, 4 and 9 do not have a common factor. 9 does not have an x, so this one cannot be factored. In number 16, between a 14 and a 16, 2 is the greatest common factor. This one has an x, this one has a y, so the greatest common factor is just going to be 2. So, set it up. There's a subtraction sign. Okay, now, we said our greatest common factor is 2. It comes out. Now, 2 times what is 14x? 2 times 7x is 14x. 2 times what is 16y? 2 times 8y is 16y. So, 2 times 7x is 14x minus 2 times 8y is 16y. You have just factored that expression. Now let's go to number 7. In problem number 7, the Finn's monthly income can be represented by the expression 25x plus 120, where x is the number of hours worked. Factor the expression 25x plus 120. Well, the greatest common factor between 25x and 120 will be 5. Set it up. Put your 5 here. Now, 5 times what is 25x? 5 times 5x is 25x. 5 times what is 120? 5 times 24. And there you have a factored expression. Now, in the Building on Essential question, explain how the greatest common factor is used to factor an expression. Use the term distributive property in your response. Well, an example of what you could write down here would be the distributive property, I'm just abbreviating it here, shows that A times B plus C equals A times B plus A times C. The greatest common factor, or the GCF, is the number that is distributed to each factor inside the parentheses. All right, so now for your homework, I would like for you to do page 419, problems 1 to 10. Page 419, 1 to 10. In problems 1 to 3, you're going to find the greatest common factor for each pair of monomials. You can list the factor, make factor trees, list the factors of each, and circle what they both have in them that's alike. In 4, 5, and 6, if it cannot be factored, write cannot be factored, but you are looking for a factor that will divide each one of the terms. Pull it out, and you will set these. This will be where you have something, the parentheses, here's the plus sign. The answers will look like that in each one unless it cannot be factored. And then carefully do the word problems. They are not that hard. 7, 8, 9, and 10. It tells you to look at example 6 in each one of these problems. All right, have a good day, and I will have the answers for this page posted on the next day's calendar. Have a good day.